Hi friends, welcome back. After looking at some advantages of synchronous circuits, now let us see what a synchronous circuit with inputs look like. That means a synchronous circuit can have inputs that can control the flow from state to state, and such a thing can be a more general circuit and can implement more complicated problems very easily. So we have a circuit which of course is a sequential circuit. That means we have inputs, we have outputs, and this output after a delay feedback. So in the previous examples like counter, there was nothing like input, only the current output will decide what should be the next output and so on. Now we can go one step ahead and think, if there is input, then what other actions we can perform, or what better activities can be taken up. So one simple example could be, we have seen a up counter, we have seen a down counter. Why not try them, combining them together, and call it an up down counter? So up, let me call it down bar counter. That means we have one input called up or down bar. That means when this is 1, it should make a up counting, and when that is 0, it should make a down counting. So to take a simple example, let us start with a small problem. Let us say divide by 4 up down counter. What does it say is, we have 4 states: 0 0, 0 1, 1 0, and 1 1. So there are two possible sequences. One sequence will do up counting, one sequence will do an up counting, and other sequence will do a down counting. So how do you decide whether to do up counting or down counting? That is given by this input, and if the input is 0, it will be down counting. If the input is 1, it will be doing up counting. So how such a thing can be implemented? Yes, of course, we have our table that helps us. So if I call this A and B as the two things, so we have present state AB, and we have input up down bar, and then we have next state AB. And once we know that, then the excitation JA, KA, JB, KB can be identified. So these three are the inputs. So we have totally 8 possibilities. The state may be 0 0, input may be 0 or 1, state may be 0 1, input may be 0 or 1, state may be 1 0, input may be 0 or 1, or state may be 1 1, input may be 0 or 1. So that's a prerequisite for starting to build this state table. So now next look into state diagram and then fill up the next states. So we are at 0 0. Yes, we are at 0 0 and the input is 0. So when input is 0, we go to 1 1. We are at 0 0, input is 1. We are at 0 0, input is 1. We go to 0 1. Same way from 0 1 with input 0, we go back to 0 0. With input 1, we go forward to 1 0. From 1 0 with input 0, we go back to 0 1. And from 1 0 with input 1, we go to 1 1. From 1 1 with input 0, we go back to 1 0. With input 1, we go to 0 0. Done. Now look at this column, A column in present state, A column in next state, and then use the excitation table. 0 to 1 is 1, don't care. 0 to 0 is 0, don't care. 0 to 0 is 0, don't care. 0 to 1 is 1, don't care. 1 to 0 is don't care 1. 1 to 1 is don't care 0. 1 to 1 is don't care 0. 1 to 0 is don't care 1. Now coming to B. So look at column B of present state, column B of next state, and then fill the JB, KB. 0 to 1 is 1, don't care. 0 to 1 is 1, don't care. 1 to 0 is don't care 1. 1 to 0 is don't care 1. 0 to 1 is 1, don't care. 0 to 1 is 1, don't care. 1 to 0 is don't care 1. 1 to 0 is don't care 1. So using K-maps, we need a 8-celled K-map. Done. For JA 1001, 1001 and 4 don't cares. So this is these two pairs together can form a quad, and therefore JA A is changing and B is changing, only up is there, which is the value is 0, so it is up bar. Same way for KA, if you look at it, 4 don't cares, 1 0 0 1. 4 don't cares, 1 0 0 1. Have done a mistake. Of course, we have done a mistake. It should be 1 here, 0 here. Therefore, this is no more valid. So it is, this is one pair, and this should be one, not this. So this should be another pair, and hence JA will be B bar U bar or BU. That means it is BX nor U. Okay, KA. This is one pair, and this is another pair. So which is also same as BX nor U. Okay, now coming to JB, if you look at it, one don't care, one don't care, don't care. So each cell is either one or don't care. Therefore, all eight together we can form an octal. So JB will be one, KB. If you look at it, don't care, one, don't care, one. That means either one or don't care. So we can form an octal, and that makes KB equal to one. So we have the circuit. Okay, what should be J? J should be B X nor U. So we get B from here, and we need an X nor, and this is our U D bar input. And what about Ka? Ka is also same as that. JB KB equal to 1. So this, finally we have outputs. This is output A, and this is output B. So if the control input is high, this is going to make a clockwise movement. That means it keeps doing an up count, 0 0 0 1 1 0 1 1. If the control is low, then it makes anti-clockwise, counterclockwise movement, and it makes 0 0 1 1 1 0 0 1 0 0. So it makes a down count. So that's a example of one uh, a sequential circuit which is synchronous and has got an input. So this is possible only in synchronous circuits. It is not possible with asynchronous circuits. Such a things are not so easily possible, or anything of your requirement cannot be decided. This you can decide anything. Now, as we discussed in our previous lecture, these positions can be changed. You can have any sequence. So you can say 0 0 here, 1 1 here, 1 0 here, 1 0 1 here. So anything, and again you can use up down, or with this you can make this transitions of your liking. For 0, where should it go? For 1, where should it go? You decide anything, and accordingly this table has to be uh, corrected or recreated, and this will be done, and designing, and finally you get the circuit. It's that simple. So synchronous circuits open up a new world where anything which needs some sequence of operations can be taken up. You can design any circuit which needs some sequence of operations, where it has got some input and it produces some output. This output in this case is the state itself. Here the state itself is the output. In some cases the state do not matter. outputs are something different than the states. So we have two types of such circuits, where one circuit says output is the state itself, or another circuit which says state and input together will decide what should be the output and all that. So let's see these two types of synchronous circuits in our coming sessions. So till then, take care. See you. Bye.